Hello everyone, my name is Zhen Jialing, coming from Harbin Institute of Technology. My topic is target detecting and target tracking based on YOLO and deep sort algorithm. I will start my introduction from the following aspect. As a next generation communication technology innovation, the implementation of 5G network can guarantee high speed of data transmission, makes the high-speed data transmission possible. Under the techno support of 5G, transmission peak can reach 10 Gbps high-speed transmission rate. It solves the pain point in the video industry and provides faster and higher resolution surveillance pictures and data. This transmission plays a connecting role through the importance of home monitoring and security industry system, and is also the core link of the market share in the whole technology. Therefore, with the deepening interaction of 5G technology, one of the areas affected and reformed must be video surveillance. 5G network has a good carrying capacity for 4K video. With the improvement of 5G technology in the industry, many problems will be gradually solved. It can be used in many areas, such as security monitoring, real-time display, street view connection, and other fields. The advantage of using this algorithm is to avoid frequent switching of the ID of the target when the target is occurred or briefly at the edge of the surveillance video coverage. Based on PyTouch, this paper combines YOLO V5S and deep sort algorithm. Use YOLO V5S to train and learn on the self-made dataset, builds its own target recognition and tracking network, completes the test of target detector, and carries out target detection test on the indoor images captured by the surveillance camera, using the camera back to the HD video monitoring, using the algorithm for target recognition and tracking, specific set for indoor screen. Two main track characters occur constantly, interact to create shade. Target marginalized and the character appear images such as action set. Finally, on the test video, you can see the target tracking effect is good. All can identify the target again and give the same ID. Implementation contribute to trick. Continue to trick. The second part, target detecting based on YOLO V5S. The YOLO network is mainly composed of three main parts. The first one, backbone, a convolutional neural network that arranges different fine-grained images and forms image features. The second one, neck, a series of network layers that mix and combine image features and transmit image features to the prediction layers. The last one, head. The image features are predicted to generate boundary boxes and prediction categories, as shown in Figure 1. The YOLO V5 first uses the input, and the function of the focus layer is to copy 4 copies of it. Then, the 4 images are cut into 4 sellers through splice operation, and then concat is used to connect the false leads in dips, and the output is as follows. After that, the output is generated through the convolution layer with the convolution kernel of 32. Finally, the output is input to the next convolution layer through bits Bn and Lr. The selection of activation functions is deep learning networks. YOLO use Liang, ReLU, and sigmoid activation function as shown below. The middle and hidden layer use the Liang, ReLU activation functions, and the final detection layer use sigmoid shift activation functions. YOLO use the CSP darknet as backbone to extract rich information features from input images. The CSP structure of YOLO Wave5S is divided into two parts, bottleneck and CSP, which bottleneck is a classic radial structure. Firstly, convolution layer, then convolution layer, and finally, the radial structure is added to the initial input, as shown in the figure 3. SPP is a spatial pyramid layer. It outputs the input feature graphy through the convolution layer, and then subassemble the 3 parallel convolution cores. For different branches, the padding sizes are different. In this way, the size of each port results in the same, and then the splicing results are adapted into initial features. Finally, the 512 convolution kernel is used to restore the feature map to the size as follows, as shown in the picture. The third part, target tracking based on deep sort algorithm. The first one, motion information. First, introduced motion features extraction part. The following 8 states are described for a detection box. Test box center, longitudinal coordinates of the center of detection. Detection frame size, aspect ratio, variable space of the abscissa of the center of the detection box, variable space of longitude coordinates at the center of the detection, variable speed of the size of the detection box, change speed of aspect ratio. Based on the above, use the 8-dimensional state vector to describe the change of the detecting box. The Kalman filter here is a linear uniformity model, using the distance to measure the distance between the predictor Kalman filtering state and the newly obtained measurement value detection box, as known below. In the above formula, we can see that to perform distance measurements must go to the same spatial distribution to do. The distance calculates the uncertainty between state estimates by measuring the standard deviation and detection frame between the tracking position means of the Kalman filter. Here, to symbolic meaning, I is the tracking series number, and G is the serialized number of the detection box. deep convolution network to extract the appearance characters of the detected target. Detect and trick each frame, performing a target appearance feature extraction and sieving. When each frame is performed later, it is necessary to perform the similarity calculations of the appearance characters of the current frame. The motion characters and appearance features will be combined as a total discrimination basis. The structure of deep neural network is shown in the following figure. The network has many parameters, training the deep convolution neural network to extract the character information of the target, and train the model on the re-ID dataset. The dataset contains many images of 1,261 people, very suitable for the target tracking. The training interloss value of the network is as follows. The last output of the network is a 128 discrimination vector. Considering the test target tracking and the 5G monitoring video, the requirements of tracking algorithm are mainly pedestrian tracking, so the input size is set to 128 and 64 rectangle. Here are three definitions. The first one, initialization. The second one, freshman. The last one, disappearing. The initial, if a detection is not associated with a previous record trick, then start from this detection, initial a new goal. The freshman, after a goal is initial, and is the first three frame and normal capture and association. Then the object produces a new trick, otherwise it will be deleted. The disappear. If the ministry save time is excited, if it is not associated, then this object leaves the video screen. The information of the object will be deleted. With a high-definition monitoring video recorded by the camera, use the algorithm to identify and trick. The effect is as shown in the figure below. It can be seen that the algorithm can again identify the targets again and give the same ID to continue tracking. The first case, monitoring video objectives are short-lived due to interaction. The second case, surveillance video objective has marginalized or even briefly left monitoring. Compared to the traditional target tracking algorithm, use two-stage processing to complete the tracking test. A better solve the problem of target loss and target occlusion. And the first phase uses a small YOLO V5 algorithm to detect the target detection and pass the detection date to the next stage. The Kalman filter is an input to the sensor detector, and the estimation of the motion module is achieved, and then combined with the deep convolution network of the learning and training for the pedestrian dataset to extract the appearance model and the previous saved model. In contrast, It is determined whether or not the same goal. The second phase contains deep appearance information, which can make the track in fact the occlusion or short disappearance target. The processing speed of the monitoring video stream is also good. The single image can reach 20 milliseconds. The effects of completing the reasoning has practical value under the feature 5G video surveillance network. And this work has support by the National Natural Science Function of China, the Basic Systematic Research Project of Heilongjiang Province, the K Laboratory of Place Wireless Digital Communication, Ministry of Public Security, and partly by the Harbin Research Fund of Technological Innovation, National Execution of the Science Program during the 12th five-year plan. The author would like to thank all the people who participate in the project. Thank you for your listening.